Okay, so we're going to run through the last stage assembly of the part assembled Proteus boards. These are fresh into me. I've had them about 1 day. Done one of them already, so I know a little bit, but I am nearly as fresh as anybody else would be coming into this, and hoping to go from the top one to the bottom one. We'll be assembling the injector outputs, the VR sensor inputs, the 5-volt supply rail and the Schmitt Trigger, and very likely just a couple of little components, the main capacitor, the programming button and a small resistor that's down here that JLC couldn't populate. So yes, run through the tools that we're going to use to start with. Couple of SMD tweezers, absolutely vital. Good solder paste. This is some stuff from Wharton Metals. It's lead-free solder. Comes with a flux built in, but again, absolutely vital for the SMD work. No clean flux paste. That's an MG Chemicals one. And just get a 8341. Now, this is a watercolour pen that's got some Wharton Metals flux in it. It is a Future 315. And we've got our components. Now this is a kit that was sent over already with the correct components. Now there is on the rusEFI wiki, there is a list of these components, and that's about it. Yes. The only other thing that we need is cheap microscope, digital microscope. I'm going to try and make sure that you can see as clearly as possible in the video what is going on the microscope. The lighting in here is not as good as it could be, so I'm just trying to keep some good lighting on it. I think next time I do this I'll try and get a bit more light, but hopefully you can see quite clearly the spaces where we're gonna put the various components on. Okay, right. So if we start off with the Schmitt Trigger that's on here, and that's the ACHV17A, and in one of these little packets. There we go. So inside this little packet there is a little integrated circuit. As you can see on the screen there, it's marked AHCV17A along the top. Now, I'm not saying what I do is necessarily correct. I'm sure somebody out there is going to say, "Oh no, you're doing X, Y, and Z wrong. You need to do it like this." But they're not doing this, and I am. So I do it my way. The other little thing I'm going to do is just add a little bit more solder to these, just to the base of these H bridges, just because they're a little bit light on the solder where they've come in. and I'd rather those pads were well grounded, partly for heat reasons. I could just be being fussy, but hey, it's better to do it right than to make a mess. This future flux I like because it's nice and thin, it's easy to see through and it's easy to work through. If we begin with the Schmitt Trigger, so what I like to do is just put a little bit of solder paste down. Now this stuff is good because it comes with its flux already built in. It saves you from having to mess around and flux things all the time. Something that I have found with the SMD work, a lot of people will go for a small tip, but it turns out actually that the nice large sort of knife tip actually performs a lot better in most circumstances. Right. On these boards, the way they're marked, this little white piece here indicates pin 1. So we can line up the little dimple in our chip with pin 1. And this is where you're going to get a warts and all, because I'm going to make mistakes. A bit more light in. Okay, now the way I like to do this sometimes helps to just put down the first pin. Another little trick I use sometimes. In here is some excess flux from that future 315. Now, taking a small paintbrush, sometimes I find it useful to just move the solder paste around, thin it out, because sometimes it's a little bit thick to see what you're doing. I find this especially helpful on the big flat chips like the STM, like all of these pins along here. It can be quite good for that because the standard solder paste is just a little bit thick for the job. Try and line this up a little better. There we go. And that allows me to just line him up. One pin is tacked down, and what I can do is just pinch him down like that. Maybe the pins on this side. And I can move back over this side and just It's a little bit of a balancing act between enough light that I can see what I'm doing and too much so you can't see it on the camera. Okay, there we go. I think that's straight off a small issue. So having some hot air is really helpful for these boards. They're so small and so fine that there are times, with the best will in the world, you can get things slightly out of alignment. Okay, there we go. Okay, so every time I've done one of these, I've ended up with a little solder bridge. Now the way to solve that is to get a little bit of desoldering braid and a little bit of the flux. It'll wick out just nicely, and you can see here it's just cleared out of that gap quite nicely. So I think he's down all the way. Okay, so that's the first chip on there. Go for the 5-volt power supply next. Got a pair of little 6-channel buffers. Now these are marked 115D225. Now these have got thermal pads on the bottom. Just grab them. Drop everything tonight. Okay. And you can see this thermal pad on the bottom. Now this absolutely has to be soldered down to this little pad here. So again, same logic. This little white line next to this pad indicates that it's pin 1. and there is a little dip on the chip there that just indicates pin 1. The other thing is, there is very good pictures on the wiki page that allow you to zoom in on all of this, and you can see the little pin 1 indication there. Okay, so it's easy to get lost on these little microscopes. Alright, there we go. So, blob of solder paste on each centre. A small amount. It's much easier to do this kind of thing when you've got a stencil for it, and you can use a spreader and stencil, but we haven't got those, so we just got to do what we've got to do. And if we put a little bit too much on, we've got to take it off again. Okay, now it's chips like these where hot air is absolutely vital. There's no real way that you can get those pads in the centre soldered properly without either hot air or an infrared oven. Also, just going to use a spare last generation Proteus board as a guard, just to stop me burning my desk, because I've burnt it enough already. There we go, that solder paste is just wicking into solder. There's a couple of these where there's not quite enough solder on, so I'm tempted to just come in with the paste. And then just touch in with the iron, like that. Alright. Okay, and now the board's nice and hot. So we'll go for these two at the top here. And these are actually a pair of Max 9924 chips, and they are marked 9924 UAHB. So no, you see here, there's no actual ground pad or anything, or heatsink pad to worry about on this one. We can do these with a soldering iron. Again, same principle. We've got the little line there to indicate pin 1. And again, these have got a small dimple on to show us which one is the top. Now, because these are quite fine pins, again, I find this paste a little bit thick. And that's where the extra flux helps a lot. It just allows me to just thin it down on there. Give me a slightly better focus on this for you. Okay, so again, it's likely these are probably easier with a hot air. I did the last board with a soldering iron, so it is possible, but I think for the ease of the video, I'll just give them a little treatment with the hot air. Looks like we've got a few little solder bridges on that. And it's easy to do with these. They are, just show the camera the size of this, of these pins. That's the tip of my tweezers. Just really small pins. Okay, there we go. That's those two in place. Right, we've got a big long row of our injector drivers just along here, and these are the VNLD 5160s. And I think there's 8 in total. 1, 2, 3, 4, 5, 6. 8 of them in total. This is where I dropped one of them. Just following exactly the same technique as I used before. Put some solder paste down and then just spread it out a little bit with the flux to thin it out. Let's try and move this a little closer to the camera. There we go. So these are slightly different. These are a little bit more difficult. They've got a little chamfer on one side. It's quite hard to work out. That just indicates which side of the chip is the number one pin. I find it easiest to go by the lettering that's on them. So right now, the writing is facing me. So VNLD just here, and then 5601 along this top row of writing with the board this way. So the row of components going upward that way, and then this bottom one just here. This is where hot air can be so much nicer and easier. Now what I'm probably going to do is just stick each one of these down and then do a quick run across the top with the hot air just to tidy up and just to neaten the board up a little bit. This one's a little bit crooked, but as I pass the hot air over it, it'll straighten up. Before we can do that, we need to get the rest of them on. So again, these ones are easiest to identify by the direction of the text. Now these are upside down on the screen, so that is the VNLD along here, and that's the ST marking along that way. Okay, next one. And this is why the big wide knife tip is useful, so you can get across get all the way across the little chip in one go, all 4 pins in one go. Now you might be able to see that not all of the solder paste is melting as I'm doing this with the iron. Not such a problem if I'm going to pass over with the hot air, just simply because the hot air is just going to melt what's not there. It should flow in. Along with the rest of it, but otherwise you're absolutely going to need to get some board cleaner or something and just rinse that excess solder paste out. Okay, there we go. That's all of them tacked down. So, lazy hot air time. A little bit of extra flux on there. So the Future 315 is nice because it's nice and thin and you can see what you're doing, but it does evaporate quick, which means sometimes it's worthwhile dabbing on a bit of the MG chemical stuff, which is a good thick flux for reflowing things. Okay, there we go. You can see the remains of the solder paste just melting away there, and the chips just lining themselves up and oops, scorching my desk. And the surface tension in the solder as it melts will just line those up nicely on my pads. Okay. With these I just want to touch with the iron, just make sure they're nice and yeah, they're nicely down. And while doing it I've knocked the capacitor off. Here we go. Here's a little benefit of the long tip. Wide enough to get both sides of this little capacitor at once, if you know what you're doing. Which it's very clear I don't. is not going well. There we go. So that's one danger when working with the hot air. It is possible to remove components you didn't want to remove. Okay, so what have we got left? We've got surface mount capacitor, which this one's quite obvious. You've got these little 45-degree corners on it, and it's got nice big pads. It's nice and easy to just blob some solid paste on there. Stick him down onto the pad, and then just gently come in with the soldering iron. Try and line that up to show you. Doesn't want to play ball. Tin on this side is really not very easy to solder. There's not a lot of room, and there's a little plastic guard on the capacitor. Now the first one I did, I melted the guard a bit. I'm hoping I can do this one without melting the guard. No. I'm also trying not to stick my ugly unshaven face into the middle of this video. but if I do, you'll just have to live with it, because there's not much I can do about that. Okay, so 3 components left. We've got what is an absolutely tiny little resistor that JLC couldn't populate. It's like a grain of rice. So I'm blaming Matt entirely for the size of this resistor. I almost had trouble getting it out of the packet last time. Okay. Right, and this goes onto these 2 little pins just down here. Fortunately, even though it's tiny, it's not too hard to get onto to get soldered on. And this is where I screw it up. There we go, easy as that. And a little bit of excess solder paste just in there that I'll get out with the tip of the iron. There we go. Clean all that up. Okay. Now we've got a programming switch, which is used for putting these into firmware upload mode. Now the switch I've got is actually an MRE one. It's a little bit big for the parts, but I tested him out on the other. I tested it out on the other board, and it's just small enough to work. Don't know if it's because these particular switches are just a little bit big, or if we've got something wrong on the layout, and these should be the right size. I'm sure somebody involved in the project will let me know.
Not having much luck this time round. These are a bit big.
So let's do a quick check of that. Because this one seems to be slightly more difficult than the other one. Oh, there we go. So yeah, switch is a little big, but he is working. I'll have to look at getting some slightly smaller ones when I do some production boards, but we're all okay with that switch for these prototype ones, and I think yeah, we're safely clear of the reset there. It's not bridged across to the reset, so he's okay on there for now. And our final component is our little USB-B. He is designed to go through from the back side. Because it belongs on the connector side. Like that. Because if I grab the connectors, and the connectors are designed to go onto the board like that. This USB is just about the right height to be accessible through a plug on the top of the case. So these are solder through, and these are dead easy to get in place. Just a job for standard solder, and flux and tim. Plastic iron from the capacitor. There we go. And there we go. Full pins just soldered on. And these little earth points for the shroud, support bits, so just flood those.
Very nearly forgot the 2 fuses that go up the top here. And without any fuses, there is not going to be any 12 volt power supply. So two little fuses, just like that. And these are nice and simple, like the resistor. Couple of blobs of paste. In position. And just pin them in place with tweezers and give them a quick touch with the iron. Okay, so there we have it. One complete Proteus board.